Hello, my name is Noah Stoffel. I'm a mechanical engineering student at San Francisco State University. I'm also a member of Dr. Azadi's Fall Engineering 415 Mechatronics course, where we learn how to assemble and program simple robotic devices. Today, I'll be talking to you about an image drawing robot that uses two motor-driven cables for positioning and two dry erase markers for drawing an image on a canvas. This drawing robot is a part of the second revision of the engineering Arduino kit. This kit provides students with all of the necessary hardware and programming needed to get the robot operational. This includes two DC motors with rotary encoders and 100:1 gearboxes, a single servo motor, a lithium polymer battery, an Arduino Nano, a motor driver board, and a USB webcam. For the purposes of this video, however, I elected to use my own webcam, but the one provided will work just as well. Some values to look out for when using these scripts are base length, as well as the lengths of L1 and L2. The base is the distance between the top two connecting points of your robot's cables. This is important for determining not only the position of the robot in relation to your canvas, but also dictates the maximum width that your canvas can be. L1 pertains to the distance between the center of the left pulley and the connecting point of the left pulley's cable. The same can be said for L2, just for the right pulley and its cable. These values are important to get accurate, as they tell your code where the robot is positioned on the canvas on startup. After assigning variables to the Arduino itself and the servo attached to it, we need to find the servo positions that tell the robot when the two markers are touching the surface of the canvas. By adjusting this slider, the servo moves into position and we can record that position here. This value will then be referenced in later tasks to know when the marker is drawing on the canvas itself. You want to remember to always clear your Arduino before moving on to the next step. Otherwise, the next time you try to connect, you may have some errors. Here, you can see the base value that I referenced earlier. In my case, my base pins are located about half a meter apart. If we run this section of the script, we get a prompt to enter the previously mentioned L1 and L2 values. After assigning the Arduino and its motors to different variables, we'll be using our L1, L2, and base values to test the positioning of our robot before moving on to drawing an image. This process involves reading the angular position of the motors and converting that to a linear distance using the perimeters of the pulleys. Moving on to step 5, we're going to draw some prepared images. In this case, we're going to be using the MATLAB logo. So we can load the MATLAB logo just through the files that are provided with the kit. It also provides pathways for the sample image, so we don't have to trace it out ourselves. However, those pathways are plotted in pixels, so we have to convert those pixels into meters. So we do that by converting the pixel coordinates into physical distances using our whiteboard limits that we gathered earlier. Once we have those limits and we've drawn those paths in meters, we want to reduce that path to something a little more manageable for the robot, so it's not drawing 1,000 different dot markers for every inch or two. Just like we did before, we can find our initial Z position by inputting our L1 and L2 values. Now, as our robot moves around, these are going to vary, so we have to find new values every time we position the robot. In this case, our L1 and L2 values are 0.33 meters and 0.35 meters respectively. So, just as I explained before, we convert those distances into angular displacements by taking the perimeter of the pulley. Then, after connecting to the hardware again, we can load our servo positions and write that position to the center so that no marker is touching the board before we start. Next, while running this section, our robot will then follow each point individually. like myself, you may get some errors here if you're connecting to an extra long extension cable. So your best bet is to be plugging your Arduino straight into the USB port without any intermediary extension cables. So for our next demonstration, we're going to be taking our webcam and we're going to be recording a video from the webcam, taking a screenshot of that, and converting that into a path for the drawing robot. And the way that we do that is we first assign the webcam to a variable. Then we can preview that webcam, and we can see our robot on the wall. And if I pan the camera over here, you can see the object that we're wanting to trace out. So if we get this in frame, and we go back, we take that screenshot, we can see the screenshot appear on the right over here. Then we separate the image into different layers. That way we get a perfect black and white image, and we can trace out the path. Once we do that, we can convert that path into pixels. Using the maximum limits of the pixels, we can find how large our object is going to be in relation to the canvas. And then we convert our coordinates into segments, into straight lines for the robot to draw. And using a little bit more code, we can check our limits for our whiteboard, or in this case, our canvas. And we can plot it out onto the canvas in meters. So here we can see that the path would be in pixels. There's a little bit of artifacting here, and that's just from the edges of the image. And using this method, we can convert these pixels down into their meter equivalents. And from here we can try to refine it a little bit more just by condensing those lines, maybe connecting a few that don't work together. Now we can connect to our Arduino, load up the positions, load in our initial values, and start tracing it from there. For some reason it didn't want to record the first time I traced this, so we're going to go ahead and run it again. But as you can see, it is tracing that outline image that we took from the webcam snapshot earlier. I want to thank you all for watching. If you have any questions, you can email me here at my school email, or you can find me on LinkedIn. Thank you. Have a great day.